For this video, we are going to look at 1.3 rates of change is the first part. So learning objectives for this video. The average rate of change. Find the average rate of change of a function. Use a graph to determine where functions increasing, decreasing, or constant. That's going to be the second video we make for this section. And use a graph to look at local and absolute maxima and minima, local minima. So let's talk about the topic of this video, though. Those are the topics for the chapter, or the section, excuse me. Finding the average rate of change of a function. So average rate of change is change in input over change of output over change of input. That's delta y over delta x. You hear people talk about the delta. The delta means the change. So y2 minus y1 over x2 minus x1, or f of x2 minus f of x1 over x2 minus x1. So rate of change. Rate of change describes how an output quantity changes relative to the change in the input quantity. The units on a rate of change are, quote, output units per input units. The average rate of change between two input values is the total change of the function values, that is the output values, divided by the change of the input values. So delta y over delta x is f of x2 minus f of x1 over x2 minus x1. You could also see it, as I said before, y2 minus y1 over x2 minus x1. Okay, let's go ahead and look at example 1. Using the data in the table below, find the average rate of change between 2005 and 2010. So 2010, we're looking at this set of data, 2005 here. So we have the change in y is 2.84 minus 2.31 divided by, so that's the output values, 2010 minus 2005. So what do we have here? Looks like we're at 0.53 divided by 5, which would be, let me get my handy dandy calculator out here. And we have 0.106. That's it. Okay, moving on to the next thing. Example 2. Given the function g of t, find the average rate of change in the interval from -1 to 2. So we're looking from -1, maybe we should change colors to red, -1 to 2. So this is kind of what's happening there. So that -1 corresponds to 1. Oh, I got that wrong. Sorry about that. I was reading the wrong part. -1 is here, wow, and 2 is here. So think about that line. So -1 corresponds to 4, and then 2 corresponds to 1. And it really doesn't matter which one you go with first, so I will go with 1 minus 4 over 2 minus -1. So since I started with the 1 here, I have to go with that 2 to start at the bottom. So we have -3 over +3, so it's -1. That's our average rate of change. Even though it went down, it came back up a little bit. Okay. Example 3. After picking up a friend who lives 10 miles away, Anne records her distance from home over time. The values are shown in the table below. Find her average speed over the first 6 hours. So from 0 to 6, we have 292 minus 10 over 6 minus 0. So that's 282 divided by 6. And that would be 40... Is that 47? Let me check on the calculator. 282 divided by 6. Yep, 47 miles per hour. Okay. What is a little interesting here, if you look at just a side note here, from hour 2 to hour 3, that's 153 minus 90 over 3 minus 2, so we get 63 over 1. This is 63 miles per hour. So just a kind of a way to consider how it's not that that's a constant speed. She was going faster and then going slower. So it averaged at 47. Find the average rate of change of f of x equals x minus 2 root x on the interval from 1 to 9. So we look at f of 1. That's 1 minus 2 times the square root of 1. So it's 1 minus 2, or negative 1. F of 9 equals 9 minus 2 times the square root of 9. 9 minus 2 times 3, which is 9 minus 6, which is 3. So when we're looking at the delta y over delta x, I'll look at 3 minus negative 1 over 9 minus 1. That's 4 over 8, or 1/2. Next one, the electrostatic force F measured in newtons between two charged particles can be related to the distance between the particles d in centimeters by the formula F of d equals 2 over d squared. Find the average rate of change of force if the distance between the particles is increased from 2 to 6 centimeters. So force at 2 centimeters is 2 over 2 squared, or 2 over 4, which is 1/2. The force at 6 centimeters is 2 over 6 squared, 2 over 36, so I get 1/18. So what we're looking at is, so the average rate of change, so our delta F over delta D would be 1/18 minus 1/2 over 6 minus 2. So I got the denominator just fine, that 4. Numerator, however, so it's 1/18 minus, that'd be 9/18. So it'd be negative 8/18. So this is like saying negative 8 over 18 divided by 4, which is negative 8 over 18 times 1/4. So this would reduce here and here, leaves a negative 2 on top. And then that reduces, so we have a negative 1 on top. So we're looking at negative 1/9. Okay, let's go on to example 6. Find the average rate of change of f of x equals x squared plus 2x minus 8 on the interval from 5 to a. So f of 5 is going to be 5 squared plus 2 times 5 minus 8. So 25 plus 10 minus 8. So that's 35 minus 8. That's going to be, what, 27? And then f of a is a squared plus 2 times a minus 8. And that's it. Can't simplify it any further. So if we're looking at f of a minus f of 5 over a minus 5, we would have a squared plus 2a minus 8 minus 27 all over a minus 5. So that's a squared plus 2a minus 35 all over a minus 5. Excuse me. Now this can be factored to be a plus 7 times a minus 5 over a minus 5, so that these divide out, and we just end up with a plus 7. And that'll do it for this part of the video. Stay tuned for the increasing and decreasing parts in local extrema.